Hello again. As I said at the first time, I'm Keokim, and let me explain what is Eduthon again for those of you who missed at the first time. Eduthon is a hackathon that produces the Dash, the 42 network command running contents. Among 42 participants, each team consisted of 3 people, and without sleeping for 42 hours straight, every team created the Dash with 3 topics. In total, 12 dashes were created and 2 teams were selected as representative to present the project in CoDam and Paris. Gratefully, our team was selected as one of the 2 teams, and now we're standing in front of you. Although you will be listening to 2 Dash projects today, all 12 Dash projects are remarkable. All 12 Dash will be released soon, so if you have an opportunity, please try it yourself, and it would be great if you recommend it to your colleges. Today, I'll be presenting about our Dash project called MiniCV. CV stands for computer vision. Our project will proceed by following. First, I will briefly explain the overview of this project and about MiniCV. Then, I will continue with explaining requirements and solving procedures in detail. Last but not least, I will explain the purpose, expectations, and possibility of development of this project. As you can see, the Dash is a short-term project that can be solved within about 30 minutes to 2 hours. Our project is based on C and bitmap structure through which you can learn basics of image processing. Computer vision and image processing technology has been utilized in many different fields since long ago, and it has been spotlighted due to the development of AI technology today. There are graphic projects which involve image processing technology among 42 courses. MiniCV is a project utilizing bitmap structure, which is a mini project for beginners where they can experience the very basics of image processing technology. By the way, do you all know the definition of computer vision and image processing? Computer vision refers to a study which researches the methodology to extract meaningful information for images or videos using a computer. And image processing is a method to improve the quality of an image and send it as an image again. In other words, image processing is a previous step before computer vision. Now, let's get down to the actual presentation. This is the subject that we created with 42 project style. The task consists of 2 mandatory exercises and 1 bonus, and the tasks are related to each other, which makes it simpler to solve the others. Mandatory is a task that writes the program which restores a broken image to an original image. And the bonus is to write a program which stores augmented image from an original image. As this project is created in 42 Seoul, we chose the given image to Gyeongbokgung Palace, cultural asset of South Korea. In the introduction, it provides a brief background information of the project and Gyeongbokgung Palace. The goal of the project is to restore this beautiful but broken Gyeongbokgung Palace image to an original image. General rules are mostly similar to the C projects we proceeded in 42 usually. The contents are about normally, memory leaks, compiler flags, makefile rules, and so on. All exercises involve hints in their titles. Exercise 0 is a task that creates a project restoring discolored image to an original image. There are several types of image file which are BMP, JPG, GIF, PNG, and so on. Among this, though the capacity of the bitmap file is quite huge, since it does not compress the pixel data and store as it is, the image quality remains and the structure is simple, which allows input-output programming available without any help from the library. In this exercise, it is able to learn about the bitmap structure and color systems. Bitmap structures are provided in the subject and there are hints to implement. You will work on restoring this image to original. Exercise 1 is a task that creates the program which restores a vertically, horizontally inverted image to Exercise 2 is a selective bonus task which writes a program that allows to augment a certain part of the original image, unlike mandatory that restores a broken image. The evaluation method will proceed with two ways, automatic evaluation and peer evaluation. When source code is submitted, mandatory parts, which are exercise 0 and 1, will be evaluated with the tester written by shell script. As the bonus part, exercise 2 has various ways to augment, and it is difficult to restrict which space to focus on. The tester will only verifies that it is normally compiled and nominate, and the peer evaluation allows to evaluate the creatively implemented augmentation. When running a tester program, first check the nominating and whether it is compiled or not, and check whether the created bitmap file is same as the original through the diff command to determine whether it is implemented properly. Additionally, check whether it runs normally with exit code. This is the tester we created, and we uploaded the instruction on how to use the tester on GitHub README. Also, I will show you a demonstration. First, move the tester and original image to the working directory. Exercise 0 writes a program which restores a discolored image to an original image. This is discolored image. After restoring the color of the image utilizing the program, compare the restored image with the original using diff command. As you can see, nothing comes out after using diff command if it is completely restored. Exercise 1 writes the program which restores a vertically and horizontally inverted image to an original image. Compare the restored image to the original image diff command as well. Exercise 2 can implement the augmentation as you wish. And in our case, we enlarged a certain part of the image as you can see. Lastly, if everything is implemented properly and when you run the tester, tests all passed will appear like this. Since we visited Netherlands, I will show you restoring this colored and inverted image of census cons to an original image. So this is the destroyed image of census cons, which is discolored and inverted. And I will restore color and invert it upside down and left to right. The image is completely restored. Yay! When we were creating this task, we let many cadets experience the project by themselves and we applied their feedback to it. At the same time, we controlled the level of difficulty suitably, raised the degree of completion, and made the process light and fun. And we constructed to better understand the bitmap structure, which is the core of this task. We restricted the admissible function in order to save time and limited input-output to use file streams so that it concentrates on learning the bitmap structure at maximum. Computer vision has been studied since 1950s, and today the fields related to computer vision are broader, and especially image processing has many cases that we have already applied to our lives. To give some examples, there are improvements in image quality, variety of filters in camera application, and object or text recognition. As the technology is useful and popular, we made the Dash project to make it easier to approach this technology. The goal of this task is to understand the bitmap structure and implement simple functions of image processing. These functions are already implemented in OpenCV, and you can simply think that this task is re-implemented from a simpler version. This project is interesting since it is able to check the result visually right away, and you can feel a sense of achievement as you play a game by restoring the broken image to the original image, and by extension, reconstructing the original image as you wish. There are several algorithms available to implement image augmentation in the bonus part. Since the bonus did not specify to enlarge the image using certain method, it could be implemented in a simple way, but cadets who are interested will be able to learn deeper. As you study further, you might learn about concept of interpolation. When you convert an image geometrically, there might be a pixel that doesn't receive any information from the original. Interpolation refers to a process in inducing the value of a whole by using known values around it. As you can see here, there are various types of interpolation. And the concept of image processing that you learned here can be used in graphic projects such as MiniRT or Cube 3D in the 42 courses. And finally, this is my favorite quote and I felt a sense of empathy, especially when proceeding with this task in Eduthon. I don't even remember how 42 hours passed by. I just did my best to make dash with my team members. And now I'm here thanks to 42 and thanks to my team. Now I would like to close this presentation. I sincerely appreciate your attention today. If you have any questions, please feel free to raise your hand and ask me. Thank you all.
So for exercise 1, it was called reverse, where you had to mirror it vertically and horizontally, but isn't that just a 180-degree rotation instead?
Oh, then that can be one of the methods to implement.
Okay. So how often is like the Eduthon?
Oh, Eduthon, it was our first time.
Okay.
Do you have any more questions? Then I will ask you questions. I have some present, and if you answer, I will give it to you. What is CV stands for? Yeah.
It's like the computer view or something like that?
Computer view.
Computer vision.
Computer vision, yeah, right. Can you pass? Okay. I got 2 more questions left. Do you remember the palace, Korean cultural asset? What is the palace name? Name of palace? Oh, difficult. It starts with G.
Not entirely sure, but I guess keokimib니다.
Something else.
이 정도면 정답이다.
I think someone.
I googled it.
Yeah. During the presentation, I mentioned time of the image. What is it?
Like bitmap, TIFF, and PNG or something? I'm not sure of the last one.
So close.
GIF, PNG, EMP, and JPEG.
Yeah, that's right. Any other questions? It can be questions about project or 42 Soul or personal questions. Oh, you have a question? No? Yeah.
I have a weird question.
Yeah?
Okay. How do you count? Because I thought you count with the hand, but it's a different way than I.
I
Because
guess-
everybody's a different way. Okay.
How do you count? Oh, like this? Oh, okay.
I also have a weird question. How do you pronounce GIF?
GIF. Just GIF.
GIF, okay. That's
How do you pronounce it?
Well, there's many ways, right? You can say GIF, you can say GIF.
Oh.
GIF.
Oh, we just pronounce it as GIF.
How many students do you have in Seoul? Like, how big of a school is it?
Oh, in 42 Seoul?
Yeah.
About 1,500. We use whole building.
Wow.
So what did you do before you came to 42 Seoul?
Before 42 Seoul, I was in army for 2 years. And before that, I was in university, and my major was physical education. And I wanted to learn about computer science, so I dropped the college and volunteered the prison. And now I'm here.
And what do you want to do after 42?
Oh, after 42. Maybe I should try to get a job and make girlfriend and marry and raise my child.
What kind of girlfriend?
It doesn't have to be Korean.
What is your favorite and least favorite subject that you've done so far?
Oh. Maybe MiniCV was my least favorite project. It was so hard. And my favorite project was Born to be Root. Do you know Born to be Root? It was like a new project, and there wasn't like a reference to look at it, so it was pretty fun. And yeah.
I'm curious why you like Born to be Rude, because it's like universally the most hated project.
그래?
I just like it.
Fine.
Oh,
Did you ever cheat on the project?
cheat? Maybe I cheated in the project. I won't be here. I never cheated. I always work hard on my project. On a project. So, thank you.